Welcome to Inkhaven Presents Readings from the Archive. I'm Ben, and on this podcast I invite guests who write on the internet. They bring an essay, they read it, and we discuss it. My guest today is Avi, who has had an excellent career as a sound engineer and also has a very interesting physics blog that I enjoy. Avi, welcome to the podcast.
Thank you, Ben. Good to be here.
What's the essay that you've brought to share with us today?
Today's essay is called World Building with Gravitational Slingshots.
Excellent. Why did you select this one?
I've always had an interest in gravity and gravity slingshots, and this one has some interesting kind of sci-fi applications.
Sure. There are always lots of interesting little physics models on your blog. And then this one, I think you said it also got turned into a story.
Yes, it did, by Max Harms.
Oh, that's nice. Did you come up with the idea? Did you discuss the idea together and then he wanted to do the fiction, or how did that come about?
I pitched the idea to him. I had the idea for a story around this because there's some very unintuitive things that would happen to somebody in this situation, and I thought it would make a good short story.
Interesting.
Yeah.
And so this is a topic you've thought about for a long time.
Yeah, it is.
But you finally got to writing about it in this one.
Exactly.
Great. Well, I look forward to hearing that. Let's give that a listen.
World building with gravity slingshots. 1. Burn fuel to get fast. Burn fuel to get slow. Zero sum. Artemis II successfully completed its mission 2 weeks ago. The Orion craft returned safely, screaming back to Earth at 11 kilometers per second, 40,000 kilometers an hour, or about 30 times the speed of sound. This insane velocity was hard-won, yet life-threatening on return. Set aside the effort it took Orion to reach such massive speeds, going to the moon and back. Now even throwing away that velocity for free would have been welcome. Indeed, throwing away kinetic energy is one of the most expensive and difficult challenges of the entire mission. What if a spaceship could return to Earth minus the inferno? Is physics hiding some kind of regenerative braking scheme like we have with EVs? Now imagine if kinetic energy were a tangible, detachable thing, like a battery, and a craft in orbit could simply disconnect it and drop it in a bucket when it's ready to return. That craft would then fall gently, relatively speaking, back to the surface with no massive heat shield, no scrubbing off costly orbital speed, no 3,000-degree plasma bubble surrounding it. Not only that, this bucket would store that kinetic energy and donate it to the next rocket coming up. A large mass, which is used as a gravity slingshot, gives you just such a free boost, both going up to space and on returning. Now, I've modeled an artificially placed mass in Earth orbit, and in my attempt to design a kind of on-ramp and off-ramp for Earth orbit. And I can now report that such a gravity assist is not possible at the orbital level. However, if scaled up to a solar system level, the physics becomes more friendly and may hold an answer to much larger challenges. Now, if you had this bucket and it was full of rocket fuel for you, you would use rocket engines, which are an uncomfortable and stressful experience for airframes and humans alike. Those velocity buckets, if they were of gravitational assist, well, gravitational assist has a special comfort advantage that no rocket boost does, and we're going to get to that. 2. The gravity slingshot. A large mass in orbit around another mass can accelerate and decelerate objects via the gravitational slingshot in the frame of the central mass. So let's talk about a gravity slingshot. A gravity slingshot is a three-body maneuver. A spacecraft passes close to a moving body, say Jupiter orbiting the Sun, and it exits on a redirected path. In Jupiter's frame, the ship arrives and leaves at the same speed. But in the Sun's frame, it has gained or lost velocity by exchanging momentum with Jupiter's orbital motion. This is what's referred to as flybys, used in Voyager missions and other space missions that have enable it to reach speeds to escape the solar system. Now, imagine an artificial slingshot mass in Earth orbit that could suck rockets up when they get near it and sling them to higher orbits, or out to the moon, or to other planets. And then craft returning from deep space would whip around this and slow down for free on their way back. It would have been a helping hand in and out of Earth's gravitational well. But as I said, physics has dashed my hopes of this device, and I can explain why. If you consider the moon, now that's large and far away, 384,000 kilometers away, and it's quite massive. But it has basically never been used as a gravity assist in space missions, with one exception. So why is that? You've got this huge ball out there. Why couldn't it suck the rockets up out into space for us? Well, if you're trying to attain Earth orbit, it's useless because it's far above the orbits that we'd want to use. And if you wanted to use it to sling objects deep out into the solar system, the velocity it can give you is basically tiny. The velocity boost is a function of the orbital velocity, which is 1 kilometer per second for the moon, and that's too small. That's just not very much. Reality check. How much influence does the moon have on current spacecraft reaching orbit? Not much. It doesn't provide any help, and its influence is tiny. Now, consider the significant tides caused by the moon. For an object to offer significantly greater assistance than the moon, it would have to be nearer than the moon, or more massive, or both. And those would present even more disruptive tides than we have now. So the conclusion is, I don't believe that there is a scenario where an artificial gravitational mass can help climbing in or out of the Earth's gravitational well. And it's important to report our null result here. In short, anything near enough to help on the way out is too disruptive. If you push it farther out in order to save the Earth, then by the time the rocket reaches it, it's already out of the Earth's gravitational well. I experimented with scenarios where a moon could offer a slingshot effect to help satellites reach orbit. Given an advanced civilization and a slashing of the costs getting on and off world, I still don't see where the physics prefers a artificial slingshot mass in a planetary orbit. Stellar level artificial slingshot mass. I propose an artificial slingshot mass, an ASM, in a tight orbit around a star as the most plausible use case. Now, the tidal effects are no longer a concern because the star is huge, and who cares if you make a tide on the star? And its function would be to launch craft out to the deepest reaches of its system and to catch them effortlessly on their scorching returns. It could even be used to launch or receive interstellar missions. This would be the gateway hub of the inner planets. As an optimization, we could give the mass a highly elliptical orbit. That offers even greater orbital speeds at perihelion, albeit with more complex mission profiles. While I didn't see how a gravity assist at the orbital level could save us from re-entry heating, like at 11 kilometers per second, that is, after all, a solved problem, albeit barely. But the heat shield limitations certainly drive the mission design, but they do work. An ASM could help solve the future velocity scrubbing challenges. Nobody currently dares venture heat shield solutions for a 30 kilometer per second reentry, let alone a 100 kilometer per second reentry, say some mission returning from Neptune. They just buckle down with the rocket equation and presume we're stuck retro-rocketing our way back down the well. If your heat shields are maxed out, add more rockets. But an artificial slingshot mass in a tight solar orbit could turn that 100 kilometer per second return into a solved 11 kilometer per second problem with zero fuel cost. And symmetrically, they can just as well accelerate a ship up to the same velocities, shoot them out to the outer reaches. Now, of course, manned missions to Neptune are not on anybody's roadmap. This is the tech level of future centuries. We are world building. Yet we are world building based on a specific technical challenge we see on TV today. And as long as one is building such a capable civilization, they can also claim that the orbital reentry has long been solved with space elevators or mass drivers or your future tech of choice. The special sauce, where an ASM blows away a rocket. Having found a niche for an ASM, let's plan a mission. Suppose you have an ASM in a highly eccentric orbit, dipping well inside Mercury's orbit. If you were to point your rocket to meet that mass at its low point, as it's screaming past the sun around 4 times Mercury's speed, it will whip your rocket speed up by 20 kilometers per second in a short period of time. That acceleration would happen in minutes. You'd probably think you need to invest in some good crash couches, but don't bother. When you picture a ship completing a hairpin turn at speeds that would squash the pilot, then consider that an object in a gravity slingshot is actually in free fall. No matter how tight the turn, how fast they did a complete 180, this is a form of orbit, and they would not feel any acceleration. Einstein would explain to you they merely traveled in a straight line through the curved space-time of the slingshot mass.
All right, welcome back. Well, thanks very much for reading that. I very much enjoyed listening to your recounting of that blog post, which didn't bear as much resemblance to the blog post as other people's recountings do. You were taking some liberties with the text and improvising a little bit.
I guess I do that when I read.
What did you notice differently reading it out loud relative to when you had just written it?
Well, I try to relate it to, it is a technical topic. So, if I'm reading it, I'm reading it to a person, and suddenly I have someone I want, I'm explaining something to, and so I'm thinking about a person I'm bringing that to.
Where did your interest in physics stem from? How long has that been something you've been fascinated by?
I've pretty much always enjoyed physics. Going back to high school and college, I liked my physics courses, and I didn't work with physics specifically in my career, although, audio was applied physics. So it's just something I always had an interest in. And then when I started blogging, the things I was most interested in exploring had to do with gravity and orbits and things like that.
How did you start blogging? You've got lots of little physics models and things on your site. What was the impetus there?
Well, one of the things I really wanted to do in this next phase of my life was to do science explanations. I actually was thinking I would be a YouTube science explainer, and I just kept holding off. And I
can see
too much of a perfectionist because I've worked in audio a lot, and I wanted the audio to be perfect, and I wanted the lighting to be perfect, and it just never got off the ground. And then one day I said, well, why don't I just write the script? And then I started banging out articles. And I said, well, seems to be where my momentum is. So nice. I'm gonna write physics articles.
That's great. Did you get any feedback on the early ones, or were you just monologuing into the void?
It is a lot of, because I got my independent site. It for the most part, it feels like it's off into the void. I've reached out to some science writers and people I know, and gotten a little bit of feedback.
That's
but
nice.
I haven't quite got that Hacker News hug of death.
Nice.
So, yeah.
So it is relevant that none of the space rockets we send up are attempting to use the moon as a slingshot in any particular way. So I guess it would have to be much bigger and much nearer in order for it to have any effect.
Exactly.
Yes, I guess.
And then the tides would be destructive.
Oh, is that the
right? So that's the problem, is that if you were to put something up there that would be a boost to rockets, it would be more of a gravitational influence on us than the moon is.
Yes.
Which would be bad. We don't want that.
Yeah, I don't quite know how quickly those tides would get bigger, but I can imagine them getting quite.
Well, if it had a greater gravitational influence than the moon did, because it would be pulling rockets up more than the moon does, right? The tides from this thing would be bigger than the tides we have now from the moon. Let alone if the two were lined up and we had a combined tide of the two.
Yep.
So yeah, it's just out of the question.
That makes sense.
And I did mention that I tried to sort of go into my little world builder or kind of some sandbox and said, okay, well, what if I had a planet that was really tide resistant, right? So what if it didn't, if it was like a rocky planet, no oceans, or if it didn't have tectonic plates, maybe the tides wouldn't bother it as much. We wouldn't have volcanoes erupting in high tides. But just working the numbers through, I kind of learned that there's not a good hard science case for that being. So if I ever see that come up in a sci-fi novel, I'm going to really look at their numbers. But I didn't give up on it, so that's why I found I would probably the even more energetic, uh, the more powerful example, which is not just getting off your planet, but like getting out of your star system.
Yeah. And did you suggest to Max the story idea, or did you?
Yes. So what happens in the story is a reveal of the point I make at the very end, which is if you think of a gravity slingshot, which is a very evocative thing, like it's a slingshot and you're the shot, right? And you are the shot. You think of a F1 car going around a hairpin turn, right? Except you're, at tens of thousands of kilometers per second. And so you're thinking it would absolutely, puree you. And then what physics tells us is that that's a form of orbit and you would be weightless the entire time.
Oh, interesting.
Yeah. So I just spoiled Max's article. But but that was the vignette which I had thought up is like, oh, so what happens if, so take somebody who knows their way, who knows the ropes, right? You've got a crew, who's done this slingshot maneuver a bunch of times. They've been in and out of the inner reaches, outer reaches, right? And then like a space reporter comes along and, and they're like, okay, get ready for the slingshot. And they're all like, strapping in their couches and stuff. And then, like one person like the cat, like drinking tea or something, right? And the reporter's getting ready to get, absolutely flattened into his couch. And then they get into the slingshot and they're like, we're in orbit, right?
That's very funny.
Yeah.
So, and just so I understand, just let me ask noob physics questions. So, is this specifically about a smaller planet orbiting or a smaller body orbiting a larger body? Because I think we do use like planets for changing our speeds and changing our angles substantially.
Yeah.
But it's specifically about the smaller body around a larger body that we're talking about.
Well, it's a three-body thing. Where one body is a spaceship.
Yeah.
So you have a spaceship plus two other bodies.
Yes.
So the spaceship needs these two bodies. It could be the sun and a planet, or the sun and its artificial mass. In Max's story, the artificial mass is like many thousands. It's a black hole, which is many thousand times the mass of the sun. I mean, he went all out with it. But any two bodies where one's orbiting the other, you are using the orbital motion of one, and as a source of velocity for your ship.
Yeah.
And if I can explain the kind of the core idea behind a slingshot, which is I think the thing that people don't often understand, and I didn't understand the first few times I understood it, is if you think of doing a slingshot around Jupiter, right? We often think of the gravitational field around a planet as a gravitational well, right? It's you fall down into it, right? And if you do a near approach of a planet, you kind of zoom in and then back out. So if you're going down a hill and back up the other side of the hill, like of a bowl, why would you come out faster? How do you gain energy there? And the answer is the bowl is moving. In the bowl frame of reference, you didn't. So Jupiter sees you coming along. You come in at whatever kilometers per second. You exit at whatever kilometers per second. But the whole thing was moving relative to the sun. I'll give you one more, maybe more intuitive but more abstract example, which is it's sometimes described as an elastic collision, something bouncing off of something. Yeah. So imagine I take a rubber ball that bounces perfectly and I throw it off that wall. It just comes back with the speed I gave it.
Minus a little friction energy.
Yeah. Physics always ignores that stuff. No friction, no heat. Right. Now, imagine the wall's moving toward me. Imagine I threw that ball off the front of a speeding freight train.
Yeah. Much faster.
It comes back faster than you threw it.
Yes.
It gains energy from the thing it bounces off of.
That makes sense.
So that's how slingshots work, is they gain energy from the thing they're slinging around. And when I say gain energy, that can be in either direction. So you can be coming back from Neptune and you fired your engines at some huge speed to get, so you didn't take 10 years to come back. And now you got to slow down And so you'd be able to do the same thing. You're basically throwing your rubber ball off of a receding train.
Yeah.
So it's a free energy source in either way.
You seem to think a lot about how to deal with like three-body issues in space. You've also got your little simulator of trying to get something into orbit.
Mm-hmm.
I guess that's just an interest of yours.
Yeah, orbits are just so cool.
Yeah.
I haven't run out of cool things to do with orbits yet. And just gravity is just it's so simple. This pulls on this. It pulls. The bigger the thing is, the more it pulls. The farther away they are, the less they pull.
Were there any books or anything in particular when you were younger that got you interested in physics?
I wish I could find. I have no idea what this calculus book was. I must have been like maybe middle school or early high school when we got the Radio Shack TRS-80 Model 3 with actual pixel graphics, not just text. Like one of the first things I wanted to do was, so it was probably around when Star Wars came out. Star Wars Tatooine had 2 suns. So we're
3 bodies.
Yeah. Well, not that wasn't 3 bodies. But I was thinking, I wonder if a planet would do like a figure 8 between its 2 suns. Like, what would the orbit look like? Answer is they don't do figure 8s. But I was like, I want to see, like how, like, I wanted to make a space. I wanted to make things orbit things on my TRS-80, and I had no idea. I had no business trying to create this, and I heard somewhere like you're supposed to use calculus, and I don't know where I found a calculus book. I looked all over for like how does a planet do figure 8s around 2 suns? It had nothing about that. I was like, okay, calculus is useless. Okay, forget calculus. And I tried to figure out how to. Anyway, I tried to figure out how to do this thing, and I think at some point, like it moved like 2 pixels, and I was like, oh, I got motion, and I forget what happened next. But reading through, actually digging in and figuring out these equations from some calculus book when I was way over my head was something I remember doing. So that's not a particular author, but that's a book experience I remember that goes as early as you can go.
How old were you at the time?
Oh yeah, like I said, it must have been young teen, 14 or
nice,
13 or 14. Yeah,
that's great.
Yeah.
I have a sense that your goal coming in was to write a fair bit of physics stuff, even though I don't know that it has been the majority of your output. While
it's been a tiny minority. I think it's my second physics article.
Why did you apply initially why did you want to come to Inkhaven?
I wanted to write. Well, I wanted to write more physics, but I wanted to write. And this was clearly the structure that would I knew would work for me. It really was. I want someone to make it right.
Remind me how you heard about it.
I don't recall exactly. Yeah, one of the blogs, probably somebody off of Less Wrong or Hacker News or something. I was just kind of skittering my way across the internet and saw a blog entry, which I don't remember what it was, but it referred back to this. So,
I see. And then you put in, that makes sense. Yeah. How is it? So you had some goals to write more, which you have done?
I am still here, so I have.
Yeah, it's day 27 or so.
3 to go.
That's right. What surprised you about the writing that you've done here?
Oh, so my writing has been a huge surprise. As I said, I've written 2 or 3 sciencey articles, and apparently, what was really in my heart was to chronicle my life and career, and so I've written a couple dozen memoirs, recounting interesting things that were interesting to me, at least on audio gigs, and story of building my company and shutting down in COVID and deciding what came next, and so it's been it's been a fabulous time for me to kind of get those memoirs out, because they are things I've been wanting to write about. I would come back from a gig and I would work with very exciting situations, and people say, you really should write this up someday. And so it had been on my on my list.
Yeah, I remember you showing me on the first call we had all your map of all the pins of all the places you'd done gigs.
Right.
Which was a very pin-filled map of the States and a few other spots.
Yeah. When I first started working in audio, like probably right around 2002 or so.
Mm-hmm.
I was just around when Google Maps had, like you could actually had custom maps.
That's fun.
Yeah, and I started putting a pin wherever I worked, and I kept it up the entire time.
Yeah.
So.
Which piece of writing that you've done here at Inkhaven came the easiest? Which flowed out of you the smoothest?
I had one which really fit together well as a story, and I'm not going to say I composed it like completely, from scratch. It's something I'd had some notes on before, which was a story called "The Smell."
Oh yeah, I love that one.
Yeah, and I'd always, and I had like I said, I had a bunch of stories like that where I was like, I really need to write this up, and so that was one that it involved, neurology and audio and just kind of thinking from first principles and
a little mystery.
And a little mystery. It was a detective story. So yeah.
I think I recall you got some feedback from Scott Alexander on that.
Scott Alexander, yeah. I put myself up, on the big board. I think one of his first feedback sessions. So and that was very helpful. And I still have my notes from that session that I want to integrate back. But I'm happy to say there was still some of the essay left when he was done. So we didn't have to delete all of it. So
he liked it as well.
Yeah,
I think he had some. Yeah, I mean, we're all somehow being reminded of the basics by Scott. He's like, sections should have a point, and then they should end, and you don't need to repeat this point 3 more times at the end. That's a good point.
And what's like amazing is like how I didn't see that I was doing that. You get so into a piece, and I'll confess, I thought I'll put this one up there because this is the one that's got no fat on it. This is the tightest. This is my tightest. I've gone over this one a million times. Like, this is the one that this one's ready to go.
That's really funny.
And he found all his fat in it, and I was like, "You're absolutely right. Why is that paragraph in there? What was I thinking?" Yeah,
that's great.
So it's great to get other eyeballs on it.
What was the hardest piece to write during Inkhaven?
Maybe this one. So one thing I've found, just talking about Inkhaven in general, is that it's hard to write every day. It is really hard. No individual piece, but there's a cognitive fatigue, and I think that one reason I ended up doing more memoirs is they don't. I'm not going to say they're easier because they're hard, but there's a particular kind of mental work that goes into the science piece. And, that's not, I may have written 2 science or 3 science pieces this month, but I tried a few more, and they just don't kind of come together in the course of a day. And I've tried to kind of get things, going in the background while I get my daily thing done. But anyway, this one, I thought it was important to report the null result, that I thought there could be a slingshot effect you could use to get off of a planet. And, I spent a lot of time working on that, and I was like, okay, this is not going to happen. So, if I started with the successful case, it would have been less work, and maybe I think it is important to mention it.
I didn't feel the essay was weaker for that.
Okay. Yeah. But the point is, you asked what was the hardest thing to write, like, going down like rat holes and then saying, okay, now I need to find a different approach that works.
How long did you work on and think about this idea during Inkhaven?
So the day I wrote it, I probably spent like 10 hours on it. Like, I didn't do anything. I just I was like, I'm going to get this done. And I buckled down and did it.
But you in the morning were like, I would like to write a piece about slingshots.
It's like today's the day I'm going to do that slingshot piece.
Had you already chatted with, I don't know, Max about it?
Yeah. And it's something I've been like, I have a lot of threads in my, to write list and things in various stages. So the core idea has been around in my list for a long time. I didn't that morning say, I think what about,
I see.
Yeah. So pretty much, Yeah, any of the science stuff I've done.
Did you have a long list coming into Inkhaven?
Oh God, like 50. Yeah, I have a huge backlog of things. Yeah, I have a huge backlog of things I still want to write. Like I remember in my Inkhaven, what do you want to write about? And I was like, I really want to write about the acoustics on Mars, which are unique, and that if life like megafauna were to evolve on Mars, their hearing would be so different from ours because there's this really weird acoustical property of the atmosphere on Mars. And
I need to know one more detail about this.
well, so that was one I just couldn't get to. So the speed of sound on Mars depends on frequency. Now, the reason that is interesting is because...
But is it about something gas in the air that's very different?
It's because of the CO2. It has this particular... The molecules have this particular weird relaxing effect, like in between the way... I'm not a like a chemist person, so I don't really understand the chemistry, but there's a particular quality to the CO2 molecules in the Mars atmosphere that makes sound travel at different speeds depending on its frequency. Now, I just want to clarify that because, we know that sound can travel, the speed of sound isn't, a super, solid thing here. It can vary with temperature and humidity and all sorts of things. It travels different speeds in water, but it always travels, in a given place, the speed of sound is the same for all frequencies, all pitches, high and low.
So you say different frequencies. What percent variation are we talking about? Are we talking like 0.1% change in speed? Are we talking about 100% change in speed?
So it's enough that it was audible to, and this is how it came up, to one of the more, I forget the name, one of the more recent Mars missions actually has microphones. And this was like a passing mention in a NASA paper where they used a laser to pulverize a piece of rock, and they videotaped it or whatever, and they recorded the audio from this, and the sound when it traveled back.
That's so much fun. We're going to send a rover to Mars, and what are we going to do? Just destroy rocks with lasers.
Totally. Why else? Is that, if you had a laser, is that not the first thing you would do? Come on.
Send it to Mars. Destroy things.
Yeah. The helicopter. They didn't shoot the helicopter. So anyway, there's this passing thing about, and then the sound was recorded on mics, and of course it travels differently at different frequencies. And I'm like, what? What? Where is the YouTuber explainer about this? So I looked into it a bit. It's not a huge effect, but it is kind of profound because, I think the word is, it's dispersive. It disperses sound. So, if you were to strum a chord on your guitar 100 meters away, the low notes would arrive to me later than the high notes. And that would not happen here on Earth.
Yeah, that'd be really annoying if I was trying to play Bach or something and the bass line arrived at half beat later.
But, and I remember what I put in the application was I think something like xenoacoustics. Imagine a creature that evolves in that atmosphere. Their hearing would have evolved with that built in, and they would already reassemble. It would not sound smeared to them. They're just like how our eyes, we see two different images, right? But we don't see double. Our brain takes those two images and actually uses them to construct a 3D model. There's a rich amount. So now, an ear that evolves in a dispersive atmosphere, when it hears a sound, it constructs a 3D model of how far away that thing was. We now have built-in range information in every sound.
Oh, that's crazy.
Yeah.
They imagine them coming to Earth and being like, I can't tell how far things are based on the notes that they're
exactly producing. Another great sci-fi scenario. How people go there and then the sound's all smeary to them, and but the natives, they sound fine to them.
You've got to just do a constant partnership with Max Harms. I don't know how many sci-fi authors do that, where there's the science ideas guy and then the writer guy. I've not heard of it very much, but perhaps you'll keep it going, or perhaps you'll start writing the stories yourself.
I could try that.
That'd be fun. That'd be fun. Um, what in your writing are you the proudest of that you've done here at Inkhaven?
Well, as you know, we need to reach 500 words per day. And I think I did the most high labor intensive posting in that I decided to write one posting in haiku. And that is a terrible way to get yourself to 500 words. It took me 39 verses.
Oh dear. I think
I
read
really
that
enjoyed
one.
that. I enjoyed it, and I posted them up in a poster at our fair, but by the cafe.
One of them was in Hebrew.
Only halfway.
That's true.
I explained to you what that is. That's it says I can't speak Hebrew, but I can't speak Hebrew, but I can say I can't speak Hebrew.
Yeah.
It says it in Hebrew, but I did match the syllable count, of course.
Certainly.
Yeah,
But yeah, they were lovely. I was glad to print those off for
Yeah.
the fair.
yeah.
Um,
So and not just haha, I got there, but it's like I'm the haiku guy. I kind of carved that space out, and it's nice to have something that I do that's recognizable here. So
yeah. That was lovely. I'm curious. What was the best writing feedback or advice that you got here at Inkhaven?
yeah, Scott gave me great feedback on the smell on my medical mystery, and as I've kind of leaned in towards memoirs. When I arrived, I immediately kind of connected up with Steve Shue, our physics guy, and
Our physics guy, our genetics guy, our startups guy, our everything guy.
Well, I write physics, and he certainly knows that stuff really well. I was like, I'm going to be coming to you with all my physics articles, and at one point I said to him, Steve, I changed my major. I'm working with Alexander Wales now in the memoirs department. So Alexander's been awesome, giving me feedback, both at the Scott Alexander level of the sentence structure, but often I would go to Alexander Wales about where does this fit? Help me let me look at bigger questions. Does this work? Or, I can find sentence problems, but I see structural problems with this, and give me an example of someone who solved this, and he does. So it helps that someone who's well read or read everything at the last Inkhaven, and can point me to the post from there.
That's lovely.
Yeah,
That's great. Did anything surprise you about what it's like to be here over the course of the month? Anything about the people or the environment or the structure of the event?
Yeah, it's a very surprising thing. It's just very surprising. You can ask me what was surprising. Yeah, I know you want to know what was surprising, but it's just surprising.
You didn't expect to see such a thing exist.
No, but it's like, okay, so so there was an issue one time which you helped resolve for me, with some behavior, right? And I remember you saying that was not okay, and me saying, okay, I'm glad that wasn't okay, but I didn't really know. That's probably too vague, but somebody had been off in a place they shouldn't have been, and I was like, yeah, okay, I guess, and
Oh, right,
right, and I was like, kind of a mind of like, okay, I kind of don't know, what is anything goes or some things go, right? So
Sure.
what doesn't go?
Sure.
So it's been very hard to, sometimes it's hard to calibrate.
Yeah. It's a pretty high openness sort of place where people are crazy in other ways.
So I come in, and I think I'm the oldest resident here, and I know that there's going to be cultural things that I don't connect with.
Yeah.
Right. So I'm already trying to just be, I can't
Accepting.
impose things. Yeah, I'm very accepting in general.
Yeah.
I'm just not a judgmental person.
Yeah. No, it's fun having such a wide diversity of interesting, curious people at the same place.
Yeah.
At the same time.
Yeah.
But yeah, you might be the oldest resident. You're not the oldest person here.
No.
We've had Mr. Friedman, Mr.
Right.
Scott Sumner, a
Yep.
couple of those folks.
Yeah. And that's been meeting David Friedman and chatting with him. I was making White Russians, and we were talking about the White Russians, so that was cool.
Oh, I'm sad I missed that. Yeah. And is there anyone else's writing here that you've enjoyed reading while you've been here in particular?
Certainly, some of the residents, Natalie, Drew, the stars. And it's really inspiring. And so, okay, here's a surprise. One of those surprises, which is like, duh, in retrospect. So I came here thinking, okay, I'm here to be around other writers. Well, I mean, we're not writing on the same thing. We're each writing our own thing, right? So it's kind of like going to a coffee shop, right? There's energy, people are industrious. But at a coffee shop, I'm writing my thing, and the guy over there is working on a spreadsheet, and I don't ever see his spreadsheet. But we're all kind of working in parallel. We're body doubling, whatever, co-working. And then also reading each other's output. And I was like, oh yeah, we're writing to each other, like quickly, and as I mentioned, I didn't have a huge readership coming in here. So immediately my readership tripled because I was up to 50 people. I mean, there were some eyeballs, right? And I'm reading theirs. And suddenly I think to myself, we're writing to each other. That gets into the whole meta thing, which I never meta posted. I'm happy to say, I am not a fan of meta posting. I didn't come here to hear your thoughts about Lighthaven.
No,
I mean, presumably you didn't have any before, so you were here because you had thoughts about something that was interesting, and I want to hear what you think of the world. But, put it in the big post in the Slack, right?
Yeah.
Anyway, but that said, I sense I'm writing with a sense of an audience now, which is definitely different.
Oh.
I occasionally dropped some, Inkhaven reference. So that was just the chemistry and the audience and writing to each other and the exchange of ideas and exchange of memes in the Dawkins sense of a meme being an idea which is replicated and passed through a society.
Mm-hmm.
So that was a cool thing.
Nice.
Yeah,
I'm glad to hear it.
yeah.
Has this changed your intentions or desires for blogging going forwards?
Yes, absolutely. I don't say my intention. I always had the intention.
Yeah.
The intention for several years, and I got 6 articles done. It's changed my belief that it can actually get done. Nobody claims they're going to leave here and keep blogging every day.
One person did, and they did for 5 months last time, but that was insane.
Okay.
Did you meet, I won't say her non-pseudonymous name,
Okay.
but Margarita Lovelace is her blog, but she's a lovely lady.
Okay.
Anyway.
Yeah. So nobody thinks that, but I believe there's a group that does community once a week.
Yeah, for Inkhaven.
And I think Justice is like the last survivor of that, perhaps.
There's like 4 less survivors
Okay.
who've done it continuously.
All right. So I would absolutely 100% be down for that. I know some people from this group who are talking about staying in touch. A lot of them are Bay Area, so I'm not Bay Area.
Yeah, where are you based again? Boston?
Boston, East Coast in general. Yeah.
That makes sense.
Yeah.
There's a couple of East Coast people here.
Yeah.
I think Viv is from the East Coast, so
okay.
you can go hang out with her.
Okay, I didn't realize it. Okay. Oh, that's right. Yeah, we talk about where she's moving to. But yeah, so does it change my outlook on blogging going forward? Absolutely. I don't really call it blogging. I want to. But developing this body of science articles and yes, putting together this history of cool things that happened in my life. I ended up one of the articles, which I think turned out rather well, but was very difficult to write, was about it's called Bad Backs, and it's about the history of scoliosis through 3 generations, starting with my father and through me and to my son, and that was a lot of heartbreaking research, not things I had ever known through my family, but reading about some of the realities of orthopedic treatments in my father's day. My father was treated at the Hospital for Ruptured and Crippled Children in New York. How's that for a name? The Hospital for Ruptured and Crippled Children. Yeah, how Dickensian, right? Anyway, so that's something which
I've brought a
was
rupture child to
poor
your
ruptured child.
care.
Get the patches out. Um, and that was not something I planned. So that was a real surprise. That was not something I planned to write. It just came out one
That
day.
research, you'd done that prior to
No, that one was from scratch. Actually,
Oh, wow.
yeah. I don't know what started that one. And that was, yeah. And well, I wrote chapter 1. I titled it chapter 1. I don't know if there's going to be a chapter 2. Chapter 2 would be my story. So, which is a very different story. I did not go through anything like what my dad did, but my son also had significant needed significant treatment for scoliosis, and so if I want to get to chapter 3, I'm going to have to get through chapter 2.
Great.
Yeah.
Perfect timing. Because as I was about to say, well, I look forward to reading more of your writing, both in the last 3 days and the preceding entire future afterwards. Thanks so much for coming. I enjoyed reading your stuff, and good luck with the rest of it.
It's been my pleasure. Thank you so much, Ben.
All right, we'll wrap up there.
Before we wrap up, I'd just like to thank our sponsor for this episode, WordPress.com. As a teenager, many of the blogs I grew up reading were built using WordPress, such as Slaystar Codex, Don't Worry About the Vars, and Steffel Optimized. The co-founder of WordPress, Matt Mullenweg, went on to build WordPress.com, a hosting service that supports bloggers. It provides an interface that allows you to design your website and to use the near infinite family of libraries and plugins that have been built for WordPress. If you're someone who cares to be able to design your own blog, for your ideas, for your writing, and for your own aesthetic, then by far one of the best options on the internet today is WordPress.com.